Hello, everybody. Welcome to the LIUniverse. I'm Dr. Charles Liu, your host, and as always, please feel free to call me Chuck. I am here today, as always, with our co-host, Allen Liu. Hey, Allen, how's it going?
Hello, it's going pretty well.
All right. Watched any doomsday asteroids approach Earth lately?
I think we've all been watching the same one,
Mm,
but it's the 2024 YR4. Yeah,
yeah. Now
it's not quite a doomsday asteroid, but
Well, as you know, we did a little short on our LIUniverse channel about this, and the odds of it hitting us are going to go higher and higher and then go to zero as we know that it's going to miss us for sure. But it's kind of fun to be watching it, isn't it? It makes people a little
yeah,
nervous, a little fun.
yeah, it's a little bit nerve wracking, I guess. I think the size comparison that I'm hearing is that it's the size of the Tunguska impactor that hit a
Ooh,
Siberian forest a
ooh.
bit over 100 years ago.
Okay. If the odds get higher than a few percent, we'll come back and talk more about that in detail. But right now,
Yeah,
we'll just kind of let it go, not worry about it, not lose any sleep, and introduce our guest for this episode, Dr. Theron Carmichael. Hello, Theron.
Hey Charles, hey Alan, good to see you guys.
yeah.
Hey, I'm really, really glad that you're here, and you're very kind to be talking to us, freezing here on the East Coast while you're in sunny and relaxed Hawaii. I
Yes,
hope the weather is cooperating there for you and having a good time.
yes, 99% of the time it is nice and sunny and very relaxed. So I'm doing all
Lucky
right
you,
over
lucky
here.
you. But no,
Yeah,
no, you've paid your dues. You've been in places that are cold and wet and cloudy before, and you did your PhD at Harvard, and you were at St Andrews or Edinburgh in Scotland. Is that right?
yep, University of Edinburgh. Yep,
Uh-huh. And now you're here in Hawaii, relaxing and
yes.
earning well-deserved rays and sun. Can't wait to talk with you today about all kinds of fun stuff. We're going to start with today's joyfully cosmic cool thing of the day.
You're
Did I get it
very
right?
close. You're very
Ah,
close to right.
ah,
Joyfully cool cosmic thing.
shoot,
You,
of the
you
day.
got you got the right first and last though, so I'll give you
All
partial credit.
I will accept. That's how I lived through my schooling life. Partial credit. That's all it is. This is a really cool paper, though. This new recent result that just got published just this past month or so in the Astrophysical Journal, and it has an astrobiology bent. Uh, Theron will know. Our Earth, our solar system, is actually in kind of like an interstellar bubble of sorts. We actually have a kind of an evacuated space, interstellarly speaking, around our solar system. And that's because of a bunch of supernova explosions that went off maybe 10, 20, 30 million years ago and kind of pushed this material away from the Earth. Now, we don't know whether or not that bubble had anything to do with the evolution of life on Earth over these past millions of years, but it's always been an interesting mystery to astronomers whether or not we can trace back anything biological here on Earth to those supernova explosions that happened 10, 20, 30 million years ago. Well, this research group has just published stuff linking a supernova explosion, which probably happened 5 or 6 million years ago, maybe 2 or 3 million years ago. But this explosion caused material to hit the Earth, this enriched supernova leftover stellar explosion material
Yeah.
hitting the Earth 2 or 3 million years ago
Mm,
and populating our Earth with radioactive iron, with uh, cosmic rays bombarding our atmosphere, and
Dang.
possibly having that interaction coincide with a flurry of virus mutation activity in deep ancient lakes on Earth. This is an amazing, I think it's super cool because you're linking all these things. And of course, the evidence is still circumstantial, but it's getting really, really interesting to know that our lives here on Earth are definitely being affected by our interstellar environment. I don't know, Theron. You are the expert in this room right now when it comes to that sort of thing, extraterrestrial life, planets, stars, interaction. Tell me what your take is on this kind of research, which I think is super neat.
yeah, I really love how interdisciplinary it is because you say, astrobiology, right? It's,
Mhm.
astronomy and biology. And a lot of the work, I've had some friends and colleagues who like do this kind of stuff. It can come from having these very detailed lab experiments, and in terms of if you're trying to simulate the environment of the space of the vacuum of space, and
Mhm.
trying to recreate those conditions and get these very this build a detailed story like what you're saying here of how life can form. But this is like, okay, say we, 5 to 6 million years ago, life's here on Earth already, right? But
Yeah.
what if you get like you're saying, this kind of influx of radiation or things that can cause mutations? How
Hmm.
does
Yeah.
that change things? That really, it's really fascinating how it really builds on this level of detail we're getting, and even maybe a surprise in some sense of like sort of thinking like, oh, there's this extra events that really might have, maybe in a similar way to how the asteroid that, speaking of asteroids,
Yeah. Yeah.
the dinosaurs really changed the history of life on Earth. This
That's
might be
true.
another example of something like that. So I think that's pretty cool.
Right. Yeah, the Chicxulub event to which you're referring, right? 65
Yep.
million years ago, that
Yep.
coincided with the extinction of the dinosaurs.
Well, the
That
ones that
happened,
aren't birds.
right? The ones that haven't evolved into
Yeah.
birds today, right? Let's be, completely
Yes.
clear about that. Yeah, uh, that happened millions of years before these explosions that we're talking about. So, that had a profound effect on life way back when the most advanced mammals from which we evolved and are like small furry creatures,
Yeah.
that are smaller than our feet and toes. But this timing, I think, is super cool because I don't know. Alan, you know that I love the X-Men and comic books and of all
Yeah.
kinds.
Yeah.
There, and I don't know if you have this, but one of the whole point about mutants in comic book lore is that some sort of radioactive event or some sort of um, various versions of increase of radioactivity here on Earth caused our genetics to be able to be receptive to mutations, right?
Mhm.
And whether it was aliens that implanted something in human DNA that made us be able to evolve into Homo superior and be able to like turn into ice or fly or whatever. I mean, this is not nearly that kind of fiction stuff, but it suggests a real scientific input from this imagined idea that we could actually turn into fiction, which is so cool in our lives. I think that's neat.
Yeah, no, I think that's pretty neat, and I know you're not trying to imply like maybe this has some real
Correct.
world implications for real life X-Men, but but
Yeah,
I
please, no
Yeah.
one think that. Nobody think that I'm trying to suggest that's the same.
it's really just great. I think like I was saying, like building up a narrative for things happening, and that really makes it a lot more exciting. I think there's always people are already very excited, at the prospects of finding life somewhere else, right?
That's
As
right.
it, as
Right.
it
Yeah.
exists, and when you incorporate this idea that like maybe this distant stars, distant supernova explosions impacted and influenced life on Earth, that
Mhm.
factors in now perhaps to what you're thinking about in your own search for life, right? Like,
Yeah.
don't rule out those systems that you might think were completely wiped out, quote unquote, by like a supernova explosion. Maybe there's
Right.
something
Yeah.
else to think about with that. But I just think it is nice. So I think it's a very sort of nuanced and like novel approach to thinking about our own sort of history, like of the life on Earth, and
Yeah.
then bridging that to future searches for life or current
Mhm.
searches for life.
Yeah, I think that's really wonderful. Tell
Yeah.
us a little bit about your own research there in this area. I know that you are a specialist in exoplanetary systems, brown dwarf systems,
Yeah.
and tell us a little bit about what you're working on right now because that's super cool.
Yeah, so most of my work, so like I currently have doing my postdoc, my second postdoc at the University of Hawaii, and my starting from my thesis work was to sort of establish a sort of protocol and means of detecting and characterizing brown dwarfs, a very certain kind of brown dwarf. That's a called the transiting brown dwarf, something that
All right.
is orbiting a star uh,
Okay.
between our line of sight. Like that's my main bread and butter.
Hmm.
Yeah.
Hmm. Now, brown dwarfs, we usually think of as this sort of
Mhm.
somewhere between a planet and a star,
Yep.
right? So there is a transiting brown dwarf, the kind that orbit other stars, is that rare or is that common?
Yeah, it is exceedingly rare,
Mm.
relative to other things that we find orbiting stars, whether that be a smaller star like in the binary star system, or giant planets even, or just planets. We
Mhm.
find planets much more frequently than we find brown dwarfs around
Hmm.
stars,
Ah,
especially in these very close orbits, which is typically how we find transiting brown dwarfs or transiting objects in general. So they're
okay.
exceedingly rare.
And what is the value of finding them then? What
Yeah.
is their rarity something really important in what they can reveal about what we know about planets and stars?
Yeah. So when you think about how a planet forms, right, or
Mhm,
even how a
Mhm.
star forms, uh, right now astronomers tend to have a pretty good idea of how, say, for example, something like a gas giant like Jupiter would have formed.
mhm.
Same
All
for
right.
how a star might have formed.
Okay.
And then when you kind of get in, there's some kind of crossover when you sort of go from a planet and increase its mass until you get to the mass of a star. In that region is the regime of brown dwarfs.
Hmm.
And we don't really know exactly how a brown dwarf formed. It
Hmm.
Oh.
might take on properties of the way a planet forms, like a gas giant planet. It might form like that, or it might form like a star. And I think the value in understanding that is you finish building up this story of the bridges between planets and stars. Like
Mm.
how we know how they're different from each other as we observe them, but how when you in this like kind of gray region, right? Like what's going on with them? Like what's happening with those brown dwarfs in that region? And I think that reveals a lot about these formation mechanisms, and all of that can tie back into understanding how planets better formed and how life might have formed out of the surrounding interstellar medium uh, to create those planets, right? So I think there's some nice connections with everything here, but I think mainly it's to understand how these brown dwarfs form, and are they more like stars? Are they more like planets? Both. I think that's what we're going for.
Yeah. So what I know about the way stars and planets form, like as independent processes, is you have a nebula, a big collection of gas and dust,
Yeah,
and then it starts collapsing down into a star once it's achieves certain requirements. And then as the star is forming, the remaining stuff that didn't quite make it into the star starts spinning around the star in this disk, and then the planets
yeah.
form out of the stuff in that disk. Is the idea then that brown dwarfs could form from the disk, or they could form from the nebula directly? Or is it
Yes,
like they do both somehow?
yes. That's the question right now. And so intuitively, I like to feel like, yes, it must be, some brown dwarfs must form like this and some must form like that, right? It's I think that's very much the case. But we can't just do the science on intuition and vibes.
Right,
We gotta
yeah.
find some
You got to find the data.
some detailed, some detailed explanations, right? And I'll note on that. So yes, one idea is after you have essentially right after that protostar is formed, any leftover material, if there's enough of it, as in enough Jupiter masses worth of material to push you over the traditional definition of a brown dwarf is 13 Jupiter masses to 80
Okay.
Jupiter masses. And
13.
yes, that's totally possible. But there are some folks, theorists and people who run these N-body simulations, especially, that can tell
Yeah.
you, well, hey, I was able to form something in the way a star forms directly from that gas in the nebula, and it's only 8 Jupiter masses. What do
Wow.
I call
Ooh.
that? Yeah, and so finding the observational data is what's going to really, I think, carry us through to something of a more fulfilling answer.
Cool.
Cool. Very, very cool. This is a good time for a question, don't you think? Alan, we have questions, as always, from so many people who listen, including
Right.
our students and our Patreons and patrons. Thank you all so much for all of your support and interest. Tell us, give us a question.
Sure. So we have a question from Ani who is asking, there are a lot more small faint stars than big bright stars. Does that mean there are a huge number of brown dwarfs in the galaxy?
Ooh, sophisticated question.
Yes, that's a great question, and yes, a few different angles you can approach this from.
Okay.
But yes, my answer is yes. There are a huge number of brown dwarfs in the
Hmm.
galaxy. So generally speaking, there's something called an initial mass function, which is basically just telling you how many stars at a given mass are just exist in the galaxy, right? Just a very,
Hmm.
very simple way to say that. And that tells us that the lower in mass we get for stars, anyway, the more and more we find
Hmm.
that we think and theorize and find in the galaxy.
Mhm.
I think this is mostly backed up nowadays with observational data of M dwarf stars. These are red dwarf stars, right?
Okay.
Uh,
Okay.
the brown dwarfs get a little trickier. So
Mhm.
those are called L, T, and Y dwarfs, but they are fainter in visible light. In fact, typically they actually tend to peak in infrared light, infrared radiation,
Hmm.
and that's just harder for us to find, right? Especially here on Earth, Earth emits in the infrared itself. So when you're looking at it, it's like you have a lot of backlight, trying to look up from the ground. We have some great space facilities that help us with this. A lot of surveys that have helped look for brown dwarfs. But yeah, so there is an exceedingly large, many more brown dwarfs in the galaxy than more massive stars. Another thing that adds on to this, which is pretty interesting, is so the lower mass a star is, and I'll consider the brown dwarfs in this as well, the longer it lives. So very massive stars burn through their fuel very quickly, and become supernova and sort of cease to exist as stars on the order of millions to hundreds of millions of years. Whereas lower mass stars, M dwarfs, brown dwarfs, right? They don't do it. They're gonna just hang out and chill out for billions and billions of years. And so this also kind of, I think, plays in a little bit to the sort of total number we find.
Very cool.
So even if there were not as big of an overwhelming proportion to begin with, they're the ones that have lasted long.
They would also last longer. Yes, that's also something to think about. Yep.
Makes sense.
Very cool. So, Theron, where do you get your data? Like about these transiting brown dwarfs? If they're hard to see and they're in the infrared, surely it's not just I can go to my backyard telescope and find these suckers, right?
Yeah, this is something we're thinking about. So there was a bit of I would say like a wager my thesis advisor made in when I was putting my thesis together. So we said, okay, well, we sort of just know historically brown dwarfs that transit stars are very rare. There is this new mission from NASA called the Transiting Exoplanet Survey Satellite.
TESS.
TESS. It was launching in 2018. This is around the time I was midway through grad school trying to figure out a thesis, and we said, well, the TESS mission is launching. It's looking for transits. Maybe it'll find some transiting brown dwarfs. And so we said, okay, let's go with that. This is one way to find brown dwarfs. So I like we just mentioned, they are these objects that themselves emit in the infrared. You can find those with infrared telescopes, as they are just sort of free floating there, even in some cases, binary brown dwarf systems. In my case, I said, well, we see a lot of stars at night, sort of main sequence stars in the optical. Let's look around those and look for signs of something passing in front of them and causing a little dip in their light. That's something that astronomers are nowadays very good at doing. And hopefully, 1 in 100, 1 in 1,000 of those are brown dwarfs. And so most of my data nowadays does in fact come from the TESS mission because it's been very successful at finding transiting brown dwarfs.
So TESS has been running for 7 whole years now?
Oh yeah, it's wonderful. Just absolutely wonderful. I can't remember off the top of my head what its nominal mission lifetime was, but it's gone into several extended missions now, which is
great. Awesome. Wow. Yeah, NASA is good at making things that last, it turns out.
Yeah, when we say they don't make them like they used to, in the case of NASA missions, that's actually a good thing, right?
Yes.
Okay. So how many of these rare things have you found, or do you think you found?
So the first transiting brown dwarf was discovered 2008. So that's it's quite late into the game as far as exoplanet sciences goes.
Yeah.
And between 10 years, 2008 to 2018, right before the TESS launch, there were 16 systems known. 16.
Wow.
Okay. From 2018 till now, the TESS mission has been responsible for an additional 32 discoveries on its own.
So it's like triple the number.
It's a lot, and the TESS so it's done quite well, and it's hard to say was I surprised a little, but also was hoping that it would find that many so I can
that's awesome
study these things.
Great. So was that about the number you expected, or way fewer, or way more, or was it just really happy that you got 30?
Generally speaking, really happy that the community in general has been able to work with this mission, and also there's been enough interest in looking for these. People will say oh, the planets are really exciting. Brown dwarfs are exciting too, and so I think that keeping that interest going is one thing. And so I'm just really happy that we've found that many and are still finding more. So
okay. All right. Well, we'll take a brief break in this episode, and we'll be back with Dr. Theron Carmichael about brown dwarfs and exoplanets right after this. And we're back here on the LIUniverse with Dr. Theron Carmichael talking about exoplanets and brown dwarfs. And right now we were just talking about TESS and how you were discovering these objects, literally doubling, tripling the number of known such transiting brown dwarf systems with one instrument, this TESS satellite, which is fantastic. Um, let's get a question in from another person. Does somebody have something for us, Alan?
All right, we have another relevant question, which comes from another student. This comes from Josie, who is asking, could there be life on brown dwarfs?
Ooh, yeah, because you were talking earlier, right, about how planet maybe, star maybe for the brown dwarf. We think
Yeah.
of life on planets, but not life on stars. So what's the story with the brown dwarf?
Yeah, so I think there's kind of two ways to answer this. One is slightly more fun than the other. So
Okay.
I'll start with the more realistic one, I guess.
All
So
right.
obviously stars, surface of orbit near too close of them are too hot. Just
Hmm.
generally speaking, too hot for life, right? They destroy a lot of
Hmm.
the molecules that we believe are necessary to form life as we know it. Brown dwarfs are indeed cooler in both ways, but by what I hear, I mean colder than stars. so, uh, but they're still, generally speaking, too hot. So,
Hmm.
uh,
Okay.
a star might be thousands of degrees on the surface. A brown
Hmm.
dwarf might be 1 or 2,000 degrees, and
Oh, okay.
a little too hot for most of the to sustain and form the molecules that we think might be useful for life.
Hmm.
But that said, those molecules they still exist in the atmospheres of brown dwarfs. So the things, the ingredients that we believe that we test in labs, that we try to observe in young protostellar systems,
Hmm.
we see those in the atmospheres of brown dwarfs. So
Oh.
that is to say, life as we don't know it certainly
Mm.
possible, right?
Right.
Yeah,
So
so
yeah,
there
Yeah.
wouldn't be like liquid water, like raindrops on a brown dwarf or
no,
anything.
different kinds of rain. There's the I think titanium oxide is a type of cloud that can
Ooh.
form
What?
Like the
in
white
some.
pigment that we use on Earth
Yeah,
for like
titanium
paint
oxide
and
is like
stuff.
paint, right?
Yeah, so
It's like
things
a
that
solid here.
yeah, the things that are fairly exotic because of the temperature and pressure conditions. Again, so
Incredible.
those conditions probably not suitable for life as we know it.
No,
But
no, no,
something
no.
else. Titanium based life.
Yeah, some very exotic things that can be created in these
Yes.
in these environments. So yeah,
Uh,
that's what we would be finding in brown dwarfs.
Wow, that's very
Crazy.
cool. The typical temperature of a blast furnace is 1,000 or 2,000 degrees Fahrenheit. The typical temperature inside a pizza oven is about 800 or 900 degrees Fahrenheit. That's like the hot kind of pizza oven. So that's like
Yeah,
the
yeah.
surface of Venus, kind of right now,
Yep.
right? So we could have really hot pizzas, at least some sort of,
They'd be pretty well cooked at that
yeah,
point.
yeah, yeah, it would be really good.
That reminds me, Chuck.
Yes,
Extremophiles, right, is another type of
right.
life, and we
Mhm.
actually happen to know of that. So I could see it in a certain, maybe the coldest types of brown dwarfs, certain extremophiles, perhaps in certain regions.
Yeah.
That's not too completely science fiction in my
Wow.
mind.
Yeah,
So
well, because I'm
yeah,
thinking like there was a little buzz a little while ago about potential signs of life in Venus's atmosphere, and those may or may not actually pan out to be life itself. But the idea that up in the upper atmosphere of something that's usually too hot lower down, you could maybe
mhm,
have a more habitable zone.
Mm,
It's possible
mhm.
maybe that's the same in brown dwarfs. Do they have that same pattern where farther up you get colder environments?
Yes, right. Yeah, in general, the farther you get away from the core of the brown dwarf, the less hot it is, right? And also the
mhm.
less pressure there is. Because pressure, that
Oh,
the
that's
crushing
true. Yeah,
pressures, I also don't imagine are amenable to most forms of life. But so,
yeah.
I think in the end, you can think of brown dwarfs as pretty extreme versions of Jupiter, right? And
Okay.
Oh,
Yeah.
so
okay.
everything we think that we can learn about Jupiter in terms of its ability to support life, uh, multiply the extremes of that by a few factors for brown dwarfs.
Mhm.
Yeah, well,
Okay.
Arthur C. Clarke wrote in 2010 Odyssey 2, the sequel to 2001: A Space Odyssey. He
Mhm.
wrote about a Jovian environment that had biological organisms with weird biochemistries in it.
Oh, wow, that's
Ooh,
fun.
In his fictional
Which,
world, there, of
which
course.
is
Yeah,
different from the Jupiter's moon Europa,
yeah.
for
right.
which we are sending a Europa Clipper, which is
Yeah.
super cool right now. That's a different dynamic, right there. And I mean, are you involved at all with any of the the long distance flights and so forth that's happening in our solar system?
Not directly involved with that, but speaking of Europa, right? The other
Yeah.
thing is, right, it's all about like finding the right temperature range, right? Like, so Europa is this cold,
Yeah.
icy moon, but like Alan was saying, maybe further down there's different different temperature environments, and we think in part could be warmed up by the tidal effects from Jupiter,
Right.
by the tidal effects the moon experiences from Jupiter. So yeah, just again, it's kind of all a balance with that. But yeah, I myself am not directly involved with any new missions going to our moons in the solar system, but they're really exciting.
TESS is pretty far out for an Earth satellite, right? Like most
Oh,
Earth satellites are way closer to Earth than TESS is.
Right. I think, famously so, the Hubble Space Telescope is, within service mission distance, we'll say,
Right, yeah.
of the Earth. Whereas, James Webb, the TESS satellite, TESS mission, too far. If something goes wrong, the very smart people, software engineers at NASA can figure out ways to tweak and tune things. But ultimately, if there's like a critical failure of something, it's kind of
we can't send an astronaut to torque wrench it or anything.
No,
that's too bad. Oh well, but this talk about our solar system is making me look at your sweatshirt, actually, Theron. And
yes.
Folks, for those of you who are just on the audio, you do not see this. Go to the YouTube and you can see the video of this episode. Yeah, he's got a something that looks like a cookie with a heart in it. Okay, we're talking about pizza ovens and baking and stuff like that. Yes. But it's actually I recognize it immediately as an emoji of Pluto, because the New Horizons picture that was coming back, there was an area of Pluto that looked like a heart in the lower right-hand corner of one particular picture. And so now we have this sort of heart-shaped, cheerful emoji going on there, which I think is marvelous. But
yeah, we love that picture.
Yeah. That's really cool. Where'd you get that? I mean, can we buy cookies that are shaped like that or something?
This shirt, and we'll call this the Pluto logo, I guess.
Okay.
Actually comes from a little thing that happens every year at MIT.
Mm-hmm.
This is called the MIT Mystery Hunt, and it's this campus-wide scavenger hunt that takes place over a few days. People form these teams to participate in the hunt, and part of the structure of the hunt is communicating with the people who designed it. And back in the day, and even still now, there will be a phone in the room with somebody calling someone in, and the team will call headquarters, or the headquarters will call them, and our team name is called Not a Planet Either. So when we would answer the phone, we'd say, "Hello, this is Not a Planet Either," and often the people then would give a chuckle and be like, "Oh, I'm also not a planet either," and then we proceed to our conversation relevant to this current hunt. But
wow.
So this is obviously a nod to Pluto being the largest dwarf planet in the solar system.
Right.
Well, wait, Eris is a little bit bigger, isn't it?
Eris is more massive, but not more voluminous.
Oh, well.
So Pluto is the biggest by one of the metrics, and Eris is bigger by the other.
By a metric, yes.
That's okay.
But yeah, that's the story behind it. Yeah, so a little sweater. We had a little team. We enjoy. The team is largely comprised of astronomers. If you didn't guess that, so
of course.
Yeah, so we have our little sweaters and things like that. Cookies are a good idea, though, Charles. I might have to get on that for next year's.
Aren't you like knowledgeable about cooking and baking and stuff? Is that not something you're famous for?
I enjoy it a lot. It is a hobby of mine that I have maintained for maybe like 16 years now, I guess.
Wow, nice.
I get maybe I'm not as old as I look, I guess, or I'm older than I look, I should say.
You started baking when you were 4. That's what it is.
Yeah. Something I've really thought hard, which is kind of funny. I've really thought hard about is recreating a sort of brown dwarf in sort of baked form.
Really?
The natural thing would be like perhaps cookies, but I think I got too ahead of myself initially when I had this idea maybe like 6 or 7 years ago, where I was like,
yeah,
I did like a sphere, and I was like, well,
brown dwarf cake.
Yeah,
like a brownie, right? Like a spherical brownie.
This is what I had to think about. But again, brownies have a certain texture, etc. So you need to really consider that, because the look is one thing, but also taste and texture are important when you're giving someone
That's
food.
right. That's
Um,
right.
Cake pops are another idea I've thought of.
Oh, yeah,
Or
because
no,
they're small too. So you got a brown
those
dwarf
are
cake
easier
pop.
to work with. Yeah, but then
Brilliant.
those are easier to work with. But I'm still working on something that I'm like happy with. So I think part of the reason why baking being a hobby of mine is
Yeah.
I spend a lot of time practicing right before
Mhm.
I share the baked goods. Well, I guess that's partly true. Any of the sort of bakes gone wrong, I'll bring in and label them as these are like failed experiments. If anyone wants to try have them, people still enjoy that.
Feed it to the graduate students. They'll eat
Yeah.
anything.
I mean, when I was a graduate student, that was the thing. That was the way to go, right? So,
Fair.
but yeah, I think what things that I think when people ask me about things I baked, often the conversation goes to like French macarons. I think
Oh,
it was pretty friendly to astronomy because again, you have a circle.
yes. Yes.
And many things in astronomy are circles or approximate circles, at least. The whole
Right.
spherical cow approximation, as that joke.
Yeah.
But the macarons are fun. I remember once in grad school I made an Hertzsprung-Russell or HR diagram using various shapes and colors of macarons, and that was quite fun.
That's
I brought it to
awesome.
a picnic.
To teach stellar evolution in
Yes,
the
yeah,
universe
and
Your
using
little almond
cookies.
meringue cookies. Yeah.
I love that. Not
yeah, so people
marvelous.
ask why are they different sizes? Like, well, these are the giant stars, these are the main sequence stars, and then so I think so as a tool for that, I've happened to employ that every now and then, but it's mostly just for fun, and I think the macarons is something I tend to lean on a lot because they're really fun for me to make and
Oh, wonderful.
widely applicable.
As a math person coming into this, I made cookies using the Einstein tile, the
Oh,
little
That's right.
hat-shaped thing that
okay.
tessellates the plane but doesn't do it in a
wow.
repeating pattern. Like,
Yeah.
Oh wow.
that was fun.
No,
Just getting a
this is so
cookie
much
cutter
fun.
and just being like, okay, I have to rotate it these exact ways, otherwise it's not going to work.
That's funny. Oh my gosh, yeah.
Cooking and baking is surprisingly common amongst astronomers. I mean, you guys may know David Helfand, who is former president of the American Astronomical Society. One of the giants in our field right now. He regularly threw parties for the students, his people at Columbia and everything like that, and just amazing chef. And Erica Hamden at the University of Arizona for a period of time, I believe she makes wedding cakes of incredible skill
That's
and everything.
impressive.
And it just makes me wonder how you feel, as a baker, how cooking and science like link together. Is it really just a completely separate thing, or is there some linkage that you find valuable or meaningful or fun?
Yeah, it's very fun. So when I first got like my sort of feet wet, so to speak, with baking, well, let's again take with the French macarons. They're notoriously difficult to make, right? And somehow here's me like I like to make them. Like that's what am I doing? When I first got started out, I would be very very meticulous and careful to like follow the recipe exactly, and like it wouldn't work out here and there. Like I couldn't figure out why. So it's I think that's very much like the scientific method. You test a hypothesis of your. Yes, you have a sort of maybe a template as a recipe for this research project you want to do, but there's going to be little things about your particular situation, the kitchen you're in, the resources you have that will tweak that a little bit, and you don't know what those are yet. So at the start anyway. And so learning that from the side of making the macarons, going to grad school in New England, humid in the summers, that changes how long you bake the macarons, how long you let them rest, for example. So I think things like that is very, very, very directly connected, at least in terms of the parts of my mind and my brain that I use to successfully make something out of the oven and to hopefully successfully do some research on in brown dwarfs. I think a lot of that uses the same parts of my mind.
That's super neat. I love that. Well, okay, so those of us who want to become world-changing astrophysicists, do not consider the kitchen to be beneath you. This may be where you learn how to become a great scientist.
I was a baker long before I was an astronomer. So
isn't that funny?
I love the chemists love baking a lot too.
Chemists, that's right. That Lessons in Chemistry, this most recent television series, like streaming series, I think, was about that. So yeah. Well, I think that's marvelous to know. We are running so low on time. I can't believe this. So I would love to ask you, like, what is a thing that you're working on right now that you're really excited about? Tell us about like a research thing that you're really, really heavily involved in right now, and so that we can like look for it in the coming weeks and months and years.
Oh, yes, sure. So I help lead this, we'll call it a working group of folks from all of the different countries, Europe, the US,
Hmm.
focused on learning more about transiting brown dwarfs. One
Okay.
of the projects in that I'm leading is to look at uh, we'll say the tiltedness, or the full, what is the obliquities of the
Oh, okay.
orbits of the
Okay.
brown dwarfs. This is something that is very tricky to do because you need really large telescopes to do it. But
Ah.
it so happens, and this is part of the reason why I have looked for a job in Hawaii.
Uh-huh.
There are a lot of big telescopes in Hawaii that I can
Yes.
use. So right now, I'm leading some projects that have collected some data using these telescopes to get a sense of, as the brown dwarf orbits its star, what is the obliquity of that orbit? And that actually tells
Oh,
us quite a bit about the formation mechanisms
I
of the
see.
brown
Right,
dwarf.
because Pluto, for example, is highly oblique in its orbit compared to the other
Yes.
Yeah,
planets.
it's how tilted that orbit is. Yeah,
Oh,
compared to
wow.
the other
So you're
things.
finding like special stuff. Wow, that
Yeah, so
sounds
that's something I'm
really
excited.
hard too, actually.
Yes, it is harder than I thought it would be, but it's been fun getting the data and learning some new things.
Wow. Well, we really look forward to seeing what the results of those things are. If we want to find you on social media, if we want to catch you on the web or in anywhere else, how can we find you?
Yeah, you can find me on, well, Twitter or X, whatever we're calling it these days. Twitter, it's at Fairbear, so it's kind of like my name, but
Oh,
Therbaer.
oh, okay.
So that's one place to find me. Also, I just have my website is where you can also just find a lot of the sort of old blog posts of the big things I've made. If you're curious to learn more about some of the things I mentioned earlier today,
Hmm.
that's just theroncarmichael.com. So
Okay.
fairly straightforward. Yeah.
Amazing.
Yeah.
Oh, well, I really look forward to it. I think I'd go over there and find some recipes and things like that. Well, we will talk again. You have so much still to tell us, and we look forward to learning from you. And then you got to give us the weather report from Hawaii, right? Just to
Oh,
make us
yeah.
feel
Will
better
do.
about what we're doing, everything. Dr. Theron Carmichael, thank you so much for being with us today. Thank you.
Thanks, guys. It was good to chat.
Yeah.
Appreciate it a lot. Thanks.
As always, Alan, our co-host, thank you so much for making this so successful.
Yeah, you are welcome as always.
And for all of you in the audience, thank you so much for joining us on this episode of the LIUniverse. Uh, if you like what you see and hear, please support us on Patreon. And as always, thank you for being a part of the LIUniverse.